guys, welcome to the second part of this week's computer lab exercise. In this part, we're going to talk about the discrete choice model using the labor supply of Mary Working Woman as the application. Both the script and data is available on Canvas, so you can work on it. You can use it to work on the second part of the assignment 4. We'll study the probability that a woman is in the labor force depending on the socio-demographic characteristic. But before we further proceed, let's install and load some external package that are needed for this part of this lab exercise. We're going to load the LPM test, car package, sandwich package, as well as the stargazer. Stargazer is optional, but it's very useful in the sense that it allows us to show the regression results side by various regression model results side by side, and in this case we're going to compare the Probit and Logit. Let's get started. First we're going to set the working directory, and then we're going to use read.csv function to read data to out. If you call stir function on this data frame, you can see that it's a data set that contains 22 variables. We are not going to use all of them. We're going to use only a subset of the as the explanatory variable, which including the education, the year of education, the year of experience, age, and number of kids less than 6 years old. We're going to use these four variables as explanatory variable. We're going to use the labor force participation as the dependent variable, which will only take two values, one if yes and 0 otherwise. So from now you may notice that you might notice that it is a binary dependent variables. So if we run a multiplied regression model on a linear dependent variable, it is also known as linear probability model. So we can still use the LPM function and provide the regression formula as usual, and we generate a LPM object. We can still call the summary function on the LPM object, but the problem is for the linear probability model, invariance is same as is going to require the heteroscedasticity robust standard errors. So for invariance we're going to need to generate the new US standard error. But for now, as there's no invariance involved in this part, it's fine that and beside linear probability model, we can estimate the Probit model, but it's no longer using the LPM function. We're going to use the GLM function. We're going to for the first argument, we're going to provide the formula, which the dependent variable before the tilde and the explanatory variables after the tilde and the data frame, and also we're going to specify the family equals to binomial link equals to Probit for a Probit model, and as you can see, GLM object is created. Similarly, to estimate the Logit model, we can still use GLM, but instead we're going to specify the family equals to binomial link equals to Logit. In order to display these regression results side by side, we can use a stargazer. We just provide the LPM object, the GLM object or LPM object that we just create in the global environment, and then you can just ignore this part for a moment. You can just take it for granted. You can see that by providing the Probit model and Logit model along with other setting, the stargazer is going to give us a very decent regression output for Probit model and Logit model side by side.